In this video, we look at how to draw the Lewis structure of the nitrate ion. But first of all, we need to determine the valential electrons that this anion has. Nitrogen is in group 15 on the periodic table, on the second period, having 5 valential electrons. Now, oxygen is in the group 16 on the periodic table with 6 valential electrons. But we need to take note of the fact that the nitrate ion carries an extra electron on it. Now, with the nitrate ion, we have 1 atom of nitrogen and 3 atoms of oxygen. So in determining the valential electrons to work with, nitrogen has 5 valential electrons, oxygen has 6 valential electrons, and there are 3 of them. And we should take note of this extra electron that the nitrate ion is carrying. So in total, we're going to have 24 valential electrons of the nitrate ion to work with as we draw our Lewis structure. Now, our next step is to choose our central atom. Now, between nitrogen and oxygen, nitrogen will be considered the most suitable central atom. Both nitrogen and oxygen find themselves in the second period on the periodic table. Nitrogen is the 7th element on the periodic table with 5 electrons in the valence shell. So for nitrogen to achieve the octet, it would require 3 electrons in its valence shell so to do. So nitrogen can achieve that by forming 3 covalent bonds. Oxygen, on the other hand, has 6 electrons would require 2 more electrons to achieve the octet and can do so by forming 2 covalent bonds. So nitrogen has 5, would require 3 more electrons to get to 8, and so can make 3 covalent bonds. Oxygen, on the other hand, has 6 valence shell electrons, requires 2 more electrons to get to 8, and it means that it can form 2 covalent bonds in order to achieve that. Now, in determining our central, the atom which makes more covalent bonds, which is able to make more bonds, is considered most suitable to be considered as the central atom. So between nitrogen and oxygen, we choose nitrogen as our central because it is able to make more bonds. So with 24 electrons to work with and nitrogen as our central atom, we go ahead with the next step to connect the atoms in a skeleton structure. So we have nitrogen and 3 atoms of oxygen. And let's connect the atoms with lines, with each line representing 2 electrons. So we have 6 electrons here distributed, and so we would have 18 more electrons to distribute, and in doing so, ensuring that the octet principle is satisfied. So we have 24 electrons distributed. However, we need to ensure that each of the atoms here involved have satisfied the octet and are happy. Now, this oxygen atom has 8 electrons in its valence shell. We have 6 of them in lone pairs and 2 here involved in the bonding. And it so applies to this oxygen atom and equally to this oxygen atom. And so all the 3 oxygen atoms are satisfied. They have achieved their octet. However, the central atom, nitrogen, has only 6 electrons around it. Now, an octet should not be less or more than 8 electrons. Nitrogen has 6. And so nitrogen here in this Lewis structure is not satisfied. So we would need to rearrange the electrons in order to ensure that all the atoms involved have attained their octet and satisfied. Now, the concept of delocalization of electrons, where there could be a shift in the position of the electrons and be converted into bonds and vice versa. So we could have this lone pair being converted into a bond, or this lone pair being converted into a bond, or this into a bond. Now, when it so happens for any of these three scenarios, then we could possibly have the following Lewis structures for the nitrate ion. So with these three potentially possible Lewis structures, each of the atoms involved have achieved the octet and satisfied. This oxygen has 8 electrons in its valence shell. This oxygen atom has 8 electrons in its valence shell, 2 lone pairs, and 4 electrons involved in bonding here makes 8 valence shell electrons for this oxygen atom. And this oxygen atom has 8 electrons in its valence shell, has achieved the octet and satisfied. Now, nitrogen here has 8 electrons in its valence shell and satisfied. And it so applies to each of the atoms in this Lewis structure, and so equally applies to each atom in this Lewis structure. Now, let's look at the next step, which would require that we determine the formal charges on each of the atoms within the various structures. Now, we will be guided by the formula formal charge on each of the atoms, the valence shell electron of the atom, minus the non-bonding electrons on the atom, then minus half the bonding electrons of that specific atom. Now, if we are and specifically consider this oxygen atom, oxygen has 6 valence shell electrons. The number of non-bonding electrons are 6. Then minus half the bonding electrons are 2 over here. So the formal charge on this oxygen atom is -1. So the formal charge on this oxygen atom is -1. It is the same arrangement for this oxygen atom. And so this oxygen atom is also going to have a formal charge. Now, if we are to consider this oxygen atom, the valence shell electrons is 6, the non-bonding electrons are 4, and the bonding electrons are also 4. So for this oxygen atom, we're going to have a formal charge of of 0. So the formal charge on this oxygen atom is 0. Now, for nitrogen, the number of valence shell electrons for nitrogen is 5. The non-bonding electrons is 0 because all the valence shell electrons of nitrogen are involved in bonding. So the non-bonding electrons is 0. Minus half the bonding electrons for nitrogen is 8. We have 2 here, and 4 here. So making 8 bonding electrons for the nitrogen atom. So the formal charge on nitrogen is +1. Now, guided by this same formula, the formal charges on all the atoms involved in the second Lewis structure can be determined as such. Now, with this determination of formal charges, the algebraic sum of this Lewis structure is -1. That for this Lewis structure is also -1, and for this Lewis structure, the algebraic sum of their formal charges is also -1. So the nitrate ion has 3 different Lewis structures. And each of these resonance structures are valid Lewis structures. They are stable Lewis structures with 1 nitrogen-oxygen double bond and 2 nitrogen-oxygen single bonds. And when multiple stable resonance structures are available for a particular molecule or ion, each of these resonance structures will contribute equally to the character of the real molecule. So the real character of the nitrate ion is going to be a hybrid of these 3 resonance structures. So we're going to have, as a hybrid of these 3 resonance structures, something of the form . So this will be the hybrid structure for the 3 resonance structures of the nitrate ion. So this is the end of my video. Thank you very much for watching, but keep watching.